Hello, we continue answering questions. We move on to part E. And I think for part E, I'll only mention one rule that will help us in our solving. So whenever we have log A times B, whenever we have this is the same as log A plus log B, and vice versa. So meaning we can interchange. If we have log A plus B, we can rewrite it as log A times B. So I thought I should mention that. Maybe let me also add, even though I don't think we'll use it in the questions above, but let me just add it. Whenever we have log A over B, this is the same as log A minus log B, like that. Okay, and then whenever we do not have a base mentioned, so say we have log A, this is the same as log 10, log to the base 10A, because usually when our base is 10, we usually don't mention, it's just written as log. I think with that we can go on to answering our questions. Okay, so question 1 says log x is equal to 2. So we can convert this to the exponential form. So remember, we don't have any base, so this is to the base 10. So that's to the base 10. So in exponential form, this is the same as x is equal to 10 raised to the power 2. So x is equal to 100. So that's our answer for question 1. Then for question 2, For question 2, we have log x 16 is equal to 4. So this, when we rewrite it to exponential form, is the same as x raised to the power 4 is equal to 16. So we will raise 16, or we'll raise a certain number to the power 4 that will give us 16. So this is x to the power 4. So we know that 16 is the same as 2 raised to the power 4. So since x to the power 4 is equal to 2 power 4, we know that the only number that so in short, the powers have to be the same and the bases need to be the same for the two answers to be equal. So it then means that our x is equal to 2. Yeah, our x is equal to 2. Okay, that's our question 2. Just take note of this. You can pause the video, then just take note of this, because I'm about to erase. So you can pause the video and then you can copy that. Okay, so that I just have more space there. So for question 3, we have log 2 x squared minus x minus 2 is equal to 2. So when you write this in exponential form, this is x squared minus x minus 2 is equal to 2 raised to the power 2. This then becomes x squared minus x minus 2 is equal to 4. Then we have x squared minus x minus 2 minus 4, it's equal to 0. Then we have so this is x squared minus x minus 6 is equal to 0. So this is a quadratic equation. So we know that since this is a quadratic equation, it then becomes easy for us to solve. We just look for two numbers. I'm sure that is 3 and 2. So this, we can write this as x squared minus 3x plus 2x minus 6 is equal to 0. Then we do that so that we factorize. So we have x minus 3, and then we have 2 x minus 3 equal to 0. So the two numbers will have x plus 2 and x minus 3 equal to 0. Okay, so from the answers that we have from these two, so we know that we'll have x plus 2 equal to 0, which will be x is equal to negative 2. That's for one of them. And then the other one, which is x minus 3 equal to 0, will simply be x is equal to 3. So those are the two values of x. Those are the two values of x. We move on to question 4. So question 4 states that question 4 is 10 raised to the power 1 minus x is equal to 6 raised to the power x. So how we can solve this? We can introduce logs on both sides. So that will be log 10 1 minus x is equal to log 6 raised to the power x. So the powers can then drop. So we'll have 1 minus x log 10 is equal to x log 6. Okay, and then we can expand this. So log 10 times 1, and then also log 10 times x. So we'll have log 10 minus x log 10 is equal to x log 6. And then from there we can we can send this that side. So this will be log 10 is equal to x log 10 plus x log 6. And then we can factorize that. So that would be log 10 is equal to, so we can factor out the x, so that we have log 10 plus log 6, like that. And then we know that remember the first rule that we had, that these, we can write this as a product. There was that rule that I had mentioned earlier on in this lecture. That whenever we have log AB, this is the same as log A plus log B. So it's the same thing that we have here. So this is the same as log 10 is equal to x log 10 times 6, which is log 60. So since we want to find x, we can divide throughout by log 60 there, and also this other side by log 60. So our x then becomes, so you can use your calculator to find log 10 divided by log 60. So we will have 0.562. Yeah, we'll have 0.562. I think we can leave it to 3 decimal places. Okay, we go on to our question 5. We move on to question 5. So for question 5, we have log 2. Then we have modulus x plus 1 is equal to 3. Okay, so if we write this in exponential form, we have x plus 1 is equal to 2 raised to the power 3. So this is x plus 1 is equal to 8. It's equal to 8. So usually when we have a modulus of x, we know that we usually have two results, right? We have the positive value for x. If x is greater or equal to 0, and then we have the negative value of x if x is less than 0. So for this one, the first result is x plus 1 equal to 8, and then so this will be x is equal to 8 minus 1, x is equal to 7. Then for the other one, when we multiply negative in there, we'll have negative x minus 1 is equal to 8. So this will be negative x is equal to 8 plus 1. So negative x is equal to 9. We divide by negative 1 there, we'll have x is equal to negative 9. X is equal to negative 9. So what also modulus entails is that when, say, you have modulus of 8 is equal to 8, modulus of negative 8 is equal to 8. So that's what the modulus does. So if we want, we can even prove our answers. If we put negative 9 inside in here, we will have so if we put negative 9 in here, in this, we'll have negative 9 plus 1 modulus there, which will give us negative 8. So negative 8 then tends to 8, which is the same as 2 raised to the power 3. So that answer is correct. So those will be our two answers. And then we go on to our last question. Okay, so I think we can solve it from here. So our last question is log 2x plus log 2x minus 2 equal to log 2 then 9 minus 2x, like that. Okay, so for this one, remember the rule that I had earlier on mentioned, to say whenever we have the bases equal, we can always multiply this, so the x and that can multiply. So this is the same as log 2, and then this multiplied by that will give us x squared minus 2x, like that, equal to log 2 then 9 minus 2x, like that. And then from here, since we have log 2 and log 2 that side, the two logs can cancel out. The logs can cancel out like that. So that will give us x squared minus 2x is equal to 9 minus 2x, like that. And then this then gives us x squared minus 2x plus 2x minus 9 equal to 0. So that will, these two will go because of subtract. So it will give us x squared minus 9 is equal to 0, which is x squared is equal to 9. And then when we find the square root of that, it's going to give us two values, so which is x, positive and negative 3, like that. So our x is equal to 3 and x is equal to negative 3. Okay, so we are done. I think we are done. Okay, thank you very much. See you in the next lecture.